Good evening, everybody. My name is Vishnu Dutt, and we are into the session number two of network automation from scratch. And in the last session, we just discussed about the importance of automation, what exactly automation is. And today is the agenda which you are going to love, right? What we are going to cover. First thing first, we will be talking about why behind operating system, right? So still, we know that we are going to learn Linux, but why exactly? Why do we need operating system at the first place, right? And if we if we learn that philosophy, then probably we can understand operating system or the importance of Linux more, right? We are going to cover uh, basically where operating system fits into a particular computer. We are going to also see what is going to happen when you switch on your computer, then what are the processes which takes place, means when operating system gets load, and what are the files, different things which happens when you switch on your computer. It is going to be an interesting discussion, right? We are going to talk about why we should learn Linux for this course. Why not Windows? Why not Mac, right? And if time permits, and I'm pretty sure that time is not going to permit, we will be talking about how to build the environment for this complete course. So if you can give me your next 1.15 or 1 hour and 15 minutes, maybe 1 hour and 30 minutes, I'll make sure that you understand the agenda well, right? And one request, right? As we all are network engineers, right? And we are learning something new, which is out of our comfort zone. We are not natural programmers. We are not natural developers, right? We understand network engineering. We understand there are some cool protocols like BGP, OSPF, MPLS, and we know that, right? We are learning this thing for the first time. This is just out of our comfortable zone or the comfort zone. So I would request everybody to take this course lightly. Okay, we are going pretty slow. Do not worry about that. And that is why I haven't put the cap on the maximum number of these classes, right? The course can be finished in 2.5 months, or maybe it can go to 3.5 months, right? It doesn't make sense to put the higher cap on this course. What I want is that we are going to enjoy this complete series. We are not going to get overwhelmed with whatever we are learning. And that is why I am going literally pretty slow, so that everybody understands, so that everybody can understand why behind things. Having said that, let's talk about the first board, where exactly we are into this course. As you know that there is only one session till now, and in the last session what we have done, we have broken down this problem of network automation. The problem was huge, right? You must have seen that Rahul and Anjali were actually part of the computer organization or the corporation, and they were facing some huge issues. 12 hours continuous job every day, right? For a month time, maybe it's a problem. And that's why Mr. Rahul and Anjali is looking for network automation. And when we broken down this problem resulted into five different pieces, right? As I mentioned, we are going to talk about each and every piece individually. And then at the end of the course, what we are going to do, we are going to combine everything together so that we have a pretty better understanding of network automation. So first thing first, as I mentioned, that we are going to learn a programming language, and that programming language is going to be the Python. We are going to learn platform, and that platform is going to be Linux. And this is the piece which we are taking first, right? At least you should understand the platform first, and then we will be starting the programming language. And it might be the case that it is going to take maybe 10 to 12 hours to understand this platform, to understand this Linux well, right? Although Linux is a simple operating system, I will prove it to you that and even I was thinking that I learned Linux maybe around 1 year back, right? And you won't believe that I was still I am still thinking, and I always think that why didn't I learn Linux to start my career with, right? Linux is one of the operating system which is really, really easy to learn, and I'll prove it to you, right? And the advantage which we have, the advantage we network engineer has, that we already know a command line interface, right? And that command line interface is Cisco iOS, maybe iOS XE or XR. We all know that, right? Or maybe any other vendor's command line interface. We already know that. And this is going to be a huge advantage for if we can learn that, Linux is going to be easy. But we need to understand the philosophy behind Linux. We need to understand the philosophy behind operating system. It is as simple as that. We are going to cover protocol in which netcon, prestcom are going to be there. I'm not going to take the name because name are in this class, names are not going to make sense, right? But they feel sometimes intimidating. What is YAML? What is YANG, right? No, we are not talking about it. When we talk about protocols, when we talk about the data modeling, definitely we are going to talk about them. But for now, the full-fledged focus is going to be on Linux for the next 10 to 12 classes, right? Having said that, let's talk about the first board where we are going to talk regarding why behind operating system. And I need your participation in this, right? So unmute yourself, and I invite everybody to think slightly in a philosophical way, right? We are going to understand, we are trying to learn why behind operating system. If we want to do that, we need to understand the mindset of the people who developed the operating system. There must be some problems, right? And they try to solve that problem, and in that process they have created the complete operating system. So if you want to understand any concept, just like TCP/IP, you need to understand, you need to see the history, that why these people were creating this TCP/IP model, why these people were creating 5 different layers, right? Now we know them because we have been studying about it, right? If we want to understand operating system, we need to understand the mindset of the people who developed it. We need to go into the history, that why at the first place somebody needed operating system. It is as simple as that, right? So I would request everybody to think slightly in the philosophical manner to understand the philosophy behind operating system, right? So what I've done here is I have an laptop, and I have shown only two important pieces of this laptop. Number one is central processing unit, which is CPU, which is a chip, right, on your inside your laptop. And believe me, it is one of the most important chip because it is doing the major work. We all know about it, right? And then I have drawn memory and I have written some ones and zeros inside it. And believe me, we all are computer engineers. Before network engineers, we are computer engineers, right? We were. We have done, maybe most of you have done Bachelor of Technology, BTech, maybe BCA, MCA also, right? But we know computers well. But if I ask anybody, can you define a computer for me? And people define it pretty precisely too, right? They say computer means a CPU, computer means a memory, right? And whatever the instructions we send inside the memory or towards the memory, CPU is going to execute it, and it is going to give us the result, right? These are one of the these are the important piece of computers, right? Memory and CPU. And the most important thing which everybody informed me or tell everybody tell me is that computer works with ones and zeros, right? We send computer instructions in the form of ones and zero, although we do not, right? We send maybe add, delete or something, right? But somebody is there who is going to convert these instruction into ones and zeros, and then CPU understand it, then CPU performs its job, right? And this is the correct definition. This is how computer work, and this is what we have been taught, right? But try to think a level, if you want to think in a philosophical manner, what exactly is happening, right? And it is very fascinating too. We have this piece of a metal. At the end of the day, what CPU is? It's a metal piece, right? It's just a metal, right? And we human being are here. We are so intelligent that we are successfully using this metal to do our most of the most complicated things, right? We are talking about artificial intelligence. We are talking about machine learning, right? At the end of the day, what is happening? Or if you talk about any logic in computer programming, which maybe most of the people means we have a fear of programming because we thought that the logic is too difficult here. But at the end of the day, what is happening here? We are giving some instruction in the form of ones and zero, only two things, right? The logic is this simple. It can be only one or it can be only zero. It is as simple as that, right? And what the CPU is doing, CPU is just rearranging them. Whatever the value it gets, right? It rearranges them on the basis of what we have learned. You all know that in our college days, we learn something called electrical engineering, right? Or there was a subject, there must be some subject which is related to uh, 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 electric currents or voltages, right? In my engineering days, I think the name was electric circuits. Then we also studied about digital circuits, right? We also studied about microprocessor, maybe 8085 or 8086, right? We also studied about digital circuits, it's done, electronics is done, and also the electronics, right? Interesting. And inside this, the digital circuit portion, we have talked about AND gate, NOR gate, which was the logic, right? How these ones and zeros are going to be changed. And human or the human being is so intelligent that he has created the logic out of only these two states, ones and zeros. Just try to think about it. It's so fascinating that only with ones and zeros, and the CPU is not doing anything. It is just rearranging the numbers, whatever we are sending, right? In accordance to our logic. So with only ones and zeros, human being has created so much logic. And in today's world, we are doing AI, ML, we are creating robots out of them, right? But at the end of the day, what CPU is processing? CPU is just processing the electric current, right? And I would say that before sleeping today, if you give it a thought for 5 or 10 minutes, then you come to know that whatever we know till now with respect to computers, that's not a complete information. That's not a complete knowledge, right? Why? Because in our college days, we were studying about electronics or electrical circuits or digital circuits or microprocessor or computer architecture. There were four different teachers, and maybe for few of you, these courses have been taught in different. These courses, I think, uh, taught in different semesters also, right? Computer knowledge cannot be complete unless you combine all these subjects together. There was nobody who can come who would who did combine all these things together so that we have a holistic or the complete picture of computers. There is a gap, right? Because if you want to understand 1 0, what are those? You need to understand normal electricity, right? If you understand how the logic is built, you need to understand the digital circuits, which you did, right? If you need to understand how computer architecture is built, you need to understand CA. But the knowledge of computer cannot be complete unless you combine all of them. Just try to think about it, right? So through this picture, I just wanted to show there is nothing related to operating system here till now, right? By the way, I'm just creating the base for that. I'm just saying this is the human. He is sending some instructions. Those instructions are going into the memory, and the CPU is actually executing or working on those instructions. But what exactly all these instructions are, right? Let's talk about it. Let's talk about it a little bit deeper. By the way, am I audible? Anybody?
Yeah, you're
Yeah.
audible.
Perfect. So let's talk about, again, we are just learning about why behind operating system, right? So now let's try to interpret the meaning of these ones and zeros, right? In the last board, I just mentioned these are ones and zeros. So what this guy wants to do is he has written some instruction for the computer, right? And those three instructions are that he wants to add two numbers. In first instruction, he's just mentioning that the operation should be add, and that add he has written in the binary format. So whenever this CPU sees these values, he will be thinking that he needs to add, it needs to add it, but it needs to add what, right? So whatever the number after written in this memory, right? Suppose I am just numbering the memory locations also. Just like if I live in villa number say 396, I can give it a name which is 396. So this is my location, right? Similarly, whatever the instruction I'm giving to memory, it is having this location number one. The second instruction is at location number two. The third instruction is at location number three. It is as simple as that, right? The meaning of first instruction is at, the meaning of second instruction is that this is going to be my first number written in binary, right? And if you calculate the decimal number, it is just 10. If you do not know about it, that is perfectly fine, right? And here is the second number, which is 0. So basically, this guy is supplying all the information that add these two numbers, add 10 plus 1. And now there is somebody inside this computer who is converting these simple instruction, which is given by this human being, into ones and zeros. And actually, those ones and zeros are getting stored in the memory of the computer. And by the way, if I'm talking about memory here, I'm talking about random access memory. What is that? We will be talking about it. But this is not the hard disk, which which are of huge capacity like 1 terabyte, 5 terabyte, 10 terabyte, right? I'm not talking about those. I'm talking about RAM, which is pretty fast, and these instructions get stored into this memory location. And somebody has programmed this CPU, right? That whenever you wakes up, whenever somebody switch you on, you just need to go to the memory location number one. Whatever is written there, just do that. And this CPU is built by many people, and it is evolving day by day, right? If I give you an example, if you try to understand it, it's again very fascinating. I'm not sure whether you have seen the transistor or not, but transistor device which looks like this, right? Which is having three pin. If you have seen any circuit board, the three leg device is known as transistor. It's a quite tiny device, right? But you can see it, right? You can see its legs. You can fit those legs into into whatever wherever you want, right? If you want to create that. So by the way, if I give you an example of the CPU, the CPU has more than 2 billions of such transistors, and every transistor is performing some task. I'm not talking about 100, 200, 1,000, 2,000, millions. I'm not talking about this. I'm talking about billions, right? Even your phone, the handheld device you have, contains 2 billion transistors in it, right? Very, very interesting. So we have programmed the CPU to fetch the instruction from the memory location number one. This instruction is going into the CPU, and then CPU understand, okay, 10110010 means this guy wants me to add something, right? And I know that whatever at the memory location number two, this is going to be my first number. Memory location number three, this is going to be my next number. which I need to add. And what I will do, I will add them and put at the memory location number 4. And if you add 10 plus 1, it is going to be 11, right? And the binary of 11 is going to be 1011. As simple as that, right? CPU has done its job. It is just rearranging these numbers. And once it rearranges these numbers, it is going to place into a memory location. And now from this memory location, you can read, right? This memory location can be shown on a particular monitor, and it is going to show 11. This is how things are working, right? Pretty easy. Although I have deliberately, I am hiding some information from you, because if I go into that, then I need to explain the complete computer architecture for you. And believe me, even I am not sure on that. But I'm reading it continuously because it is giving me a lot of fascinations nowadays. After completing college, I am in the process of combining digital circuits, electricity, and uh, I think the third thing I forget about it, digital circuits and this thing along with, yeah, the microprocessor. If I combine all these things together, believe me, the computer understanding is going to be great. Maybe this is a, topic of some means we can discuss about it at some other time whenever this knowledge is complete. But for now, the whole sole point is I have a program and CPU is executing it. Then where do we need operating system, right? And believe me, this was the model we were following, right? In 19 maybe 60s, what we used to do, there were at that point of time there was no keyboard, no mouse. Computer system were not evolved this much. 1960s, 1970s, if I talk about, right? What was happening at that point of time? So basically, at the end of the day, we all know now that memory understand ones and zeros, CPU understand ones and zeros. So at the end of the day, we need to inform to this memory, or we need to write some digits to this memory, and CPU is going to do those operations. So what we have at that point of time, we have punch cards. These are the paper, right? Where we find some holes and there are no holes some places, right? So wherever there is a hole, we call it I think a 0, and wherever there was no hole, we call it a 1, right? And we give this punch card to the computer so that computer memory can fill with these zeros and ones. Try to understand, right? For one program, maybe for 3 instructions, we are using we are using many. For one program, we are using many punching cards. And this was the effort of using computer at that point of time. Just try to understand, right? So if you want to add two numbers, just write those numbers on these punching cards, feed them into the memory, and then CPU is going to read them one by one. It is going to write that at a particular memory location, and then basically you can read it again through the punch cards. Interesting, right? So, no problem. Life was simple. Do you think life was simple? Try to understand if what if this guy has more than one program? Maybe now he wants to add and subtract and multiply too. What is going to happen? Let's talk about that also. So if we talk about what if this human who is contemplating, who is thinking loudly about the operating system, how it works, now he has three programs. Maybe this program is for addition. This is the add instruction. This is first number, second number, and this is the result which computer has put it back, right? Maybe these memory location are 0, 1, 2, 3, 4, whatever, right? We have another program, or maybe it's a subtraction program. This is the program for multiplication. Now we have three programs. Do you think the approach is going to be changed? No. We just need to make sure that CPU becomes more intelligent. How? We have put all these three programs continuously in this memory, and we are informing Mr. CPU, let's go to location number 0, execute whatever it is. If it is an add, add two numbers and put it here, right? And then the next instruction, once you finish this, do not stop. Just go into the next location to find what you need to do more. And here it is going to find the subtraction. It is as simple as that. We need to subtract this. Means this is the first number, this is the second number. I now want to subtract the second number from the first and write the output here. Similarly, the multiplication too. So we are just making the CPU more intelligent that you can do more than one program, right? But still the approach was simple, right? We are feeding this memory with ones and zeros, and CPU was reading it, and now we have more than one program. But this is just working like our access lists, right? You must be thinking where this access list has come from, because I have a habit of comparing everything with computer networking concepts. If you talk about access list, how it works is that suppose we have so many access list entries into a particular access list. How router is going to perform the task? It is going to match the packet against the first line. If it is a match, then whatever the return here, access or denied, router is going to be perform according to that. If not, it is going to go next on to the next line. Again, this router is going to match against this line, right? If it is a match, the sequence is going to be, the flow is going to be break here, and then the action is taken, right? Similarly, what is happening here? It means that basically we are going in say sequence, right? What is the meaning? The meaning is if we can, first thing first, we need to do the first operation, which is add, right? We need to run the first program, and then we can come to subtraction, and then we can come to multiplication. We cannot do the subtraction first, or maybe we can give the instruction to it, but for now everything is going into a particular sequence. Interesting, right? So previously CPU was not that aware. It was only running one program. It know where to go, where to fetch the instructions, and that is it. Here CPU is getting more intelligent, right? We are telling it do not stop after executing the one program. Execute the subtraction also, right? Now, if I talk about, let's make it slightly more complicated now, right? Okay. Here is the thing. Do you think that today's computer work like this, the previous board? And you must be thinking, what is the meaning? The meaning is just simple. I just said you just need to run first addition program and then start doing subtraction and then start doing the multiplication, right? If I say in today's world that you have a computer, and if I replace add with WhatsApp application and then subtraction with Cisco WebEx application, right? Or subtraction with Chrome application, and I just need to say that yes, you can run the WhatsApp application, you can write your messages, you are happy, right? That is perfectly fine, you can do that. But there is a restriction. If you want to open the Chrome application, you need to first complete whatever is happening with WhatsApp application, right? Or you need to close it. Mean at one time, basically, you cannot say that you are working on WhatsApp application as well as Chrome application. And the reason is just simple, right? Whatever comes first with the CPU, it is going to be executed first. Once it is done, once WhatsApp work is done, then you are thinking about running Chrome. If you are done with that, then basically you are thinking about working with this application, which is the WebEx application, right? Things do not work in this manner. You all know that. We all know that, right? It means that somebody is doing some magic here, right? Means we are successfully able to run WhatsApp application along with Chrome application, and at the same time we also can do WebEx calling also from the same computer, right? It means that there is somebody who is managing all this, who is guiding the CPU, that Mr. CPU, you need to perform some activities with this application. Maybe you can give starting 2 seconds to this application, right? And then next 2 seconds for this application, and then 5 seconds because WebEx needs some more time. You are giving 5 seconds, and then you are again switching it back. Now I am talking about in seconds, but believe me, when we talk about CPU, even 1 second is also divided into 10 to the power 6 parts, right? Interesting. We are talking about microsecond. We are talking about milliseconds here, right? Interesting. So CPU, we have made CPU so intelligent that basically it is sharing the time between application. Do you think that it is happening automatically? There must be somebody, some brain must be here, right? Who is guiding CPU that Mr. CPU just give 2 microseconds to WhatsApp application, then and the person who is sitting here, he cannot think in microseconds, right? Microsecond is we cannot process thing in microseconds, right? For us, maybe the smallest unit is maybe 1 second. We cannot figure out the difference between 1 second and then half second or 1/20th of the second. We cannot process that, right? But the CPU is so fast. It can do instructions. It can run instructions in microseconds, right? So basically, at the one time, CPU is working on at least one application, but it is giving us the feeling that it is working on all the application because CPU is so fast. But how much time this CPU should give to WhatsApp? How much time the CPU should give it to Chrome or WebEx? Who is actually managing it? This is the real question, right? And believe me, we need a manager here. And you must be thinking that why manager? We are already fed up with our own manager, and you are talking about we need a manager here. This is a software version of the manager, right? And you must agree with me now that there must be somebody, there must be something who is guiding the CPU that how much time you should give to each application. And that manager, that code, that system is actually your operating system, right? I am talking about operating system in a pretty general way. I have just give you only one application of this operating system, that how much CPU should be given to different processes or different applications. We are talking about applications, right? The second job of this manager can be, right? Suppose this memory which we have, it is only maybe 50 in numbers, right? I'm not saying GB or whatever, right? MB. I'm not talking about it. Unit can be anything, right? How much memory should be allocated to each program? This is known as memory management. Previously, what we were doing the time management of CPU, right? And of course, if I have given the starting three numbers of memory or location of memory to WhatsApp application, I cannot give the same memory to Chrome. Definitely, I cannot give it, right? Why? Because WhatsApp application instructions are already there. Who is actually managing that? That the starting three location should be given to WhatsApp. Next four are going to be for Chrome, or next six are going to be for WebEx application. Who will be doing that, right? There must be somebody, and that somebody is actually a very powerful code or program which is known as operating system. Operating system is somebody who is controlling these things. Interesting. right? Suppose if another you click on another program, right? Basically, you want to have one more program inside this, maybe the notepad, and now we do not have any memory remaining, right? Who is going to manage that? If a particular application is giving some error, he is not able to perform who is going to remove this process out, right? So if I give you a clear-cut example, this operating system is just behaving like a government, right? Then you must be thinking, why government? Because if we talk about our own government, Indian government, right? Mr. Modi is leading it. And you all know he has divided his complete cabinet into multiple streams, right? One minister is going to look after the defense, other one is going to look after the financial things, right? Other one is going to be the home minister, maybe the railway minister. You all know about it, right? As I mentioned, this manager or operating system is behaving like a government. Why? Because government actually is not doing much thing, but it is providing us the environment in which people can grow, in which our infrastructure can grow. They are just providing that environment, right? Similarly, here the operating system is doing the same. It is providing that environment so that your processes can run effectively. If I say process, it is actually your application which is inside the memory, right? You must be thinking that if we have this 50 unit of memory, but I have so many programs, where do I need to store, right? If a program is running if your program is running right now, then it should be in memory. For example, right now I'm teaching you on an application which is known as Microsoft Whiteboard, right? So what would have I done? I had switched on this PC. I have double click on this application. And what is the meaning of double click? The meaning of double click is I am telling that Microsoft Whiteboard should go into the memory so that the CPU can fetch out the instruction. If I am writing it, it is again the ones and zeros, and CPU is showing all the things at the monitor. First thing first, this whiteboard application should be inside the memory. It is as simple as that. So if a application is inside the memory, it is known as the process, and the process management work is done by operating system. I am just talking about on pretty high level things, right? And I just noticed that it's already been 38 minutes, right? Very general thing, but I request everybody in this class today, before going to sleep, just try to think about that. Do we know computer that much where whatever we boost, right? What is the meaning of these ones and zeros? How actually the CPU is working, right? Just try to combine whatever you know from the electrical background. Just try to combine the digital circuit. Just try to combine your knowledge, right? Try to think that whether you can make something out of it or not, right? Having said that, I think till this board, and if you have any doubt, please do ask, right? If you have any question, please raise your hand. If not, that is perfectly fine. And I can see Mr. Supreet is here. Mr. Supreet, please do ask your question.
Hey Vishnu, thank you. So basically, when we say that applications are running on computers, so are we talking about the application layer of the OSM model where our computer interacts with the application?
Actually, this TCP/IP, right? Just forget about it for maybe for the next 10 classes. Okay, Supreet?
Okay, Vishnu, yeah, sure.
What I'm talking about here is, see, TCP/IP is a problem. TCP/IP is solving a one particular problem. That was how two computers are going to communicate with each other. right? And that is where they have developed 5 layers. The packet are going like this and coming like this, right? It is part of your operating system, believe me, and I will showcase you somewhere. But here, let's leave about this problem was not there at all at at that moment when people were thinking about operating system, right? Try to think. People were giving punch card inside this machine so that this memory can understand that where is one, where is zero, and then CPU can understand and can work according to that, right? Because this was a huge problem, they need to create these punch cards, right? Right? So they were thinking that how to run these programs. What if we want to run more than one program? What if my memory is small and program is big? There must be somebody who is managing it. I just want to prove from these three boards that our computer architecture is simple if we try to understand it, right? And if we want to run the program via CPU, there must be some manager who is actually doing the bit which is required here, just like the government. Okay, Mr. Supreet, am I making any sense?
Yeah, Vishnu, sure, not a problem. Yeah.
Perfect. But believe me, if you give at least 10 to 5 minutes today, you won't be actually you will start doing some googling, believe me, right? It happened with me maybe 6 7 days back when I was trying to just combine all the pieces together. It happened with me, right? Just try to think philosophically that with ones and zeros we are doing, actually we are able to perform any logic whatever we think today. Interesting. Having said that, let's move to the next board, and this board is going to make a few things clear, right? So if I say here, definitely there is a need of a manager who is guiding us which application should go where, how much time of CPU it is going to get. We need to manage the memory. WhatsApp memory should not go into the memory of Chrome. There should be there shouldn't be any mismanagement of the memory, although it has many other works to do. But still, uh, we are pretty sure that we cannot work just like people in 1970s who were just giving the punching card. We need some manager who is going to manage our application, right? So first thing first, this structure, try to understand it. The core of everything is actually your hardware. And what is that hardware? That hardware is your CPU. That hardware is your memory. That hardware is your, maybe the hard disk, whatever you have. That hardware is your NIC card, right? Maybe the sound card or whatever you have. Because at the end of the day, if sound is coming, it is coming from the sound card, right? Or sound hardware. If the packets are coming, it is coming from the NIC. If data is stored, it is stored on hard disk. If program is executing, a process is doing some work, it is inside the memory. And at the end of the day, who is doing all the processing? It is done by CPU. So actually, this hardware is doing the effort, and that is it is at the core, right? But it is going to be very difficult that if I run an application, maybe the WebEx application, right? And suppose this WebEx application is saying, I will take all the CPU, 100% of the CPU should be with me for the next 10 minutes. If that is the case, if I want to run any other application like Chrome, it is not going to work, right? Suppose all these applications are fighting, no, I want 100% of the CPU. Chrome is saying, I want 100% of CPU. Even your Notepad application, which doesn't require 100% of the CPU, it is also saying, I want 100% of the CPU. This is a this is a state of mismanagement, right? And you can see that if we have a particular resource, for example, if on a particular place, if I have maybe say 1 crore rupees, and if I have many people here, right, the Agenda was that these 20 people or this 100 people will get equal amount of share from this 1 crore. But if there is there is no management, then these people can go there and take as many as they want, and there is going to be fight. It is as simple as that. Maybe government is there so that these money can be distributed accordingly. The same thing is happening here. Hardware is right there, programs are right there. If there is nobody to manage them, there is no manager, an application can take everything of that CPU. Maybe it can take hard disk, all the space, everything, right? You do not want to do that, right? If there is a matter of only one application, we do not care, right? That is perfectly fine if we make, because only one application was running. And previously in the era of 1970s, that was the thing. And then people thought, no, we want to run more applications simultaneously, once concurrently also. And that is why we need operating system. And that is what I have showcased you in this orange color here. So basically, without operating system, nobody can interact with the hardware. Operating system is the manager. These rupees here, right? Nobody can take them unless there is a permission from the government official, right? He will be distributing it. Here, operating system is going to be distributing this hardware, because hardware is just like money here, right? Hardware is the important thing. Every process, every program is fighting to get maximum of it. How much we are going to allocate, it is the responsibility of this operating system. Interesting. What operating system is doing, it is managing the memory, it is managing the time. And believe me, it is not doing only these two things. It is doing many more things than that, right? And the piece of the software which is doing the job of the government, right? Managing time of CPU, managing memory, right? Is known as kernel, right? Kernel is just like the government who is just creating that environment so that these applications can run with efficient memory, efficient CPU, or whatever they need, right? Try to understand. Kernel is again a program which is doing the major tasks. It is the actual manager, right? But suppose if you want to talk to this manager, how you are going to do that? If you have seen that if you ever logged into the and you must be, right, on the Windows operating system, if you have opened this command prompt, what you can do, you can write here some commands and system is going to execute. If I say system is going to execute, who will be executing it? Your operating system is going to execute it. For example, you can run a song from this command line interface, right? At the end of the day, who will be affected? Hardware is going to affect it, right? But who is in the middle? Operating system in the middle. But how you were able to do that? Because you have this program, this command prompt. Here we are, this is known as command prompt in Windows. And we call it terminal or bash terminal in Linux. If you are not sure about it, that is fine. But I want to say that you should have some applications through which you can access the system. If I am saying system, I am talking about hardware and operating system, right? And these are known as system programs. So kernel plus this bash or the system programs, they are combined to form your operating system. In fact, I should have written here kernel only, not operating system, right? But if you combine, kernel is the pure manager. It's just like the government. But to make government run, right, they need some supporting programs, which is known as system programs, right? Just like a bash. This user can interact with the operating system, even the hardware, through this bash. This is written This is not doing the management work, right? This is not doing the memory management, time management, but it is required that if this user want to interact with this, right? So this guy is actually comes under the system programs. We have application program which is built by the developers like WhatsApp, Chrome. These devices need hardware to perform their activity, right? For example, WebEx needs the your headphone, your microphone, right? But what if we have two such systems, maybe Microsoft Teams and WebEx, these are going to fight for them. Operating system is the one who will say that, okay, WebEx you can take now, and maybe Teams you can take later. It is not that simple. The algorithm is not like this. There are so many algorithms there, right? And believe me, this is not developed in just 1 year, 2 years, right? It took time. I think in 1971, there was I forget the name, but the person who has developed Unix, in 1971, we have an operating system with the name of Unix, right? And it is not like that we do not have operating system before that. Massachusetts Institute of Technology built uh, a operating system which is based on this time sharing, whatever I discussed, right? And Unix is built on top of that. And now, after 20 years, in 1991, I believe Linux is built on top of Unix because these were the free systems, right? Interesting history also. But the whole sole point of this diagram is that you should understand where exactly your Linux fits. It is as simple as that. Not Linux operating system. So if anybody has any doubt, any question, please do ask. Please raise your hand. I want your input that you are getting something. If I specifically take name Prashant Patil ji, Rajsekharan ji, Rakesh ji, Somraju ji, are you getting anything out of it? Is it interesting or it is boring? Anybody? Okay. Can you
Yeah.
please tell me, am I audible?
Yeah. Yes,
Okay.
Vishnu.
So any doubt you are
Yeah.
seeing here? Or we all are good?
No, yeah, no, we are good.
Okay. Is the session is getting bored or basically you are finding it little bit interesting or just like that? Anybody?
It's a plus or minus. I mean, some I feel like some are repeating.
Yeah.
I mean, which is I learned before. Some like recollecting, which is we learned during our degree and engineering courses.
This is good. This is good. Because these are really important for everybody. Means if you know them, it is going to be brush up for you. If you don't, it is going to be very crucial when you try to understand. Okay. But how many of you think that anybody that this is your means this is what you thought that operating system is the same thing which you means is the definition is closer to whatever you had in your mind? Anybody? If you want to come and speak, anyone? Means operating system is like this in your mind, or is it was slightly different? I think the same. This is good. Okay,
Yeah, I think it's same. Yeah.
perfect. So guys, speak up. I would say that in Hindi class, if you just see the session, the there were a lot of questions, and those were very interesting questions. Maybe I would take those questions even after this class. So whatever comes to your mind means do not sit means if anything is coming to your mind, just ask. So in the process, what we are going to do now is we are trying to switch on this system and we will see what exactly happens inside the system, right? Or inside this laptop. So what I'm doing here is I am pressing the power button of this laptop and want to see what is going on, right? So what is inside this laptop I'm showcasing you right here in this circle. So what we have here, we have CPU. You all know it is important piece. We have disk now. What is the meaning of disk? Disk are the storages, right? Then you must be thinking that RAM was also a storage. That is also the memory. You are right, but this is the costlier memory. And you must be thinking that if that is the case, then do you want to say that the disk storage or the 1 terabyte or 2 terabyte of storage, whatever these are not that costly? Yes, if you compare the price of RAM and this storage, you will find the RAM is way costlier as compared to disk. And the reason is RAM is way faster as compared to disk. Try to understand CPU is talking in terms of microseconds, right? If you divide 1 second with 10 to the power 6, then you are getting microsecond. Interesting. It's a pretty fast pace, right? But and it is also talking to memory. So you must understand that this memory should be fast enough because CPU is fast, and that is why we are using RAM. We are not using disk because disk is slow, and that is why it is cheaper. Memory is fast, RAM is fast, and that is why it is costlier. CPU is talking to RAM. It is not even talking to disk. Why? Because CPU think that RAM is at least at its level. There is no match of a speed of a disk and CPU, right? So what I've done is I have put Linux operating system in disk 1, and on disk 2 I have put Windows operating system. I switch this machine on. First thing first, what is going to happen? System doesn't know where the operating system is, right? What to do? So there is one more memory which is a fixed memory, and the meaning of this fixed memory is, or read-only memory is, that the content of this memory doesn't go if you switch this machine off. For example, whatever the content they are written here, if you switch this machine on and again switch this machine off and again switch it on, these contents are going to be there. It is permanent. It is permanently available in this memory, and such memory is known as basically your read-only memory. You cannot write anything on it unless there are few ways which you can through, but for most of the time this ROM is having these instructions hard coded in it, right? And we call that as firmware also. If you have heard about this term firmware, this is your firmware. Basically we write inside this basic input output system. The meaning is when you switch on this computer or the laptop, the first program which get executed, system knows that I do not need to go anywhere. I will just go into the ROM. There are some instructions written there. I will just execute those instructions with the help of the CPU. The first thing first, whatever happens, the first thing which happens is whenever we switch this machine on, the system checks that whether there is a ROM. Yes, ROM is there, CPU is there, disks are working fine, memory is working fine, keyboard is attached, mouse is there, and we call this as a post, right? Power on self-test. You must have been noticed that when you switch on this router, you must have seen this post, power on self-test. It is as simple as that, right? Once it is done, it is basically seeing everything in this program, whatever you have written in ROM. It is executing all the instruction in the ROM one by one, and the program which is written here in this ones and zero is known as basic input output system, which you also known as BIOS, right? You all know about it. And inside the BIOS, there is instruction written that which operating system to boot with maybe, and that is why I've taken the example of two disk, two operating system, and here it is going to prompt you that it has found two operating system at disk 1 and disk 1. Disk 1 is Linux operating system and disk 2 is your Windows operating system, which one you want to run. And I think you must have selected those also, right? Sometimes maybe the operating system is not present on the disk, maybe it is on the network. So you have defined here in the BIOS itself that whenever you try to load operating system, it is not there on my machine, it is there on the network. So take that operating system from the network. But where to load it? You need to load this operating system to the memory first, right? At the end of the day, the manager is actually your code. And if you want to execute that code needs to be in the memory. And that is why this Linux operating system is going to be inside this memory. Suppose it has taken one location, two location, and three location. So this is the first program which gets installed into the RAM. That is your operating system. That is your kernel. It is as simple as that. Now it takes control. The operating system takes control, and whenever you launch a program like Chrome or WhatsApp, Linux operating system or any operating system, whatever is in the memory, it is going to take the control, and it will be working as an intermediary between the CPU and the program, so that this program cannot take all the resources like CPU, memory, and everything, right? Now the manager is there. This is how your machine boots. I am simplifying it to a greater level, but I want you to think this way, because if you can think this way, you can understand the importance of operating system. This is the first program which goes into the memory, which gets executed first. And what we see here, this is your kernel which gets here. But Microsoft Windows, as you know, it is a proprietary operating system, right? We will talk about the difference. Do not worry about it. But anybody has any doubt, any problem in this slide, in this board? Please do ask, because this is good for your overall understanding. Having said that, I do not see a question here. So let's move to the next board. Till this point, we should be pretty much comfortable about the fact that operating system is the necessity in computers, right? And why it is the necessary, you all know. Mr. Prashant Patilji, please do ask your question.
Vishnu, can we call operating system like Linux or Windows as a program manager?
Yes, definitely. You can call it. And interestingly, in Hindi class, somebody was giving me the example of Halchal movie. And there is a Hindi movie, right? The name is Halchal. And the analogy was really perfect. Just means if you understand Hindi, Prashant, just have a look at it. So, but yes, you are right. You can say it's a manager, program manager, but it has so many other jobs too. I'm just giving you just the glimpse of what operating system does, right? Because it is developed over a period of maybe 50, 60 years, right? It is doing so many things, the kernel, right? But yes, at the end of the day, it is doing the work of management. If I say what government does, right? Government does. You must be thinking that there's many means foreign policies, right? Finance, so many things are doing. But there are some other operations which even you do not know, maybe the secret operations, right? But interestingly, this Linux operating system is open. Anybody can go and see the code. Windows operating system is not open, right? They haven't opened it for public. So now here is my point. Why we should learn Linux for this course? You must be thinking that we are pretty good with the Windows. Windows is an operating system. It's a great operating system, no doubt about it, right? So does the Mac also. But believe me, if I give you the philosophy behind these two operating systems, the philosophy of a Windows and Macintosh operating system is just simple. They want this laptop absolutely simple, and that is why they have created this graphical user interfaces, which are so intuitive that anybody can log into these devices and can work, right? When you switch on the Windows laptop, there is a start button. You can go there, you can launch the program, even if you haven't seen the computer in your own in your life. If you know English little bit, you can just open it and you can do something, right? You can open at least a program. You can write something there on the notepad, right? So the whole sole intent of Microsoft and Macintosh operating system was to make it user friendly. And in that process, basically, there is no doubt about it that if Windows is an operating system, we are going to have kernel, right? But when you boot up this operating system, what do you see? You see a flashy UI. It means that UI is also part of the kernel. It is so tightly integrated, and that is what making the Windows operating system a slightly bulky operating system, right? Because kernel job was very specific job, and now you are mixing UI with it, because there is no doubt about it that this is the way so that a user will feel more comfortable in the Windows or Macintosh operating system, because UI is pretty close tight with kernel, right? And that is why basically we are seeing this Windows operating system as a pretty good operating system for the know nothing learner, right? Simple. So the Windows philosophy was to make it simple and to go into this market. And believe me, 90% of the market, 95% of the market is captured by Windows and Macintosh operating system, right? Then there is an immediate question, Mr. Vishnu, why then for only 10% of the thing, why do you want us to learn Linux? Believe me, I'm talking about just the desktop market, right? In desktop market, we have 90% of Windows and this one, but there is a huge market apart from desktop too. If I give you an example, believe me, whatever the handheld device you have, whatever the mobile phones you see, and whoever mobile phone is running Android, actually it is running on a Linux version, right? So as I mentioned, the Linux kernel is neat, pretty neat. It is just the kernel and it is open for everybody. Even you can take that kernel out. You can write your program around it. For example, what Android developers of the Google has done, they have taken the kernel of this Linux operating system and they built some their own system programs, right? And you know, kernel plus program means an operating system. And if they combine this kernel of Linux with their own uh, customized application, they have created Android, and 70% of the mobile phones are on Android. It means that they are running the Linux kernel. Okay, I want to give you one more example. I'm not sure whether you know that how many servers are there on internet. There are huge number of servers are on internet, right? I'm not sure how many, but huge. Why? Because there are so many websites which are hosting these servers. There are a DNS server. There might be so many other servers, right? And believe me, all these servers are, or the maximum of these servers are running on Linux. If I give you a clear number, 66% of the server on the internet are running Linux, right? Very, very interesting. 70% of the mobile phone, 66% of the internet servers. Whatever you see, iOS XE or XR, this is running on Linux. Any other vendor, if you try to talk about maybe Arista or anybody, they are running on Linux. If I talk about networking, IoT devices, they are running on Linux. I'm not sure whether you know about it or not. I think you have heard about a name which is Raspberry Pi. It is a full-fledged computer which is available only in less than 1,000 rupees. It is going to have a chip CPU. It is going to give you USBs, right, to connect your mouse and keyboard. It is going to give you a connectivity, a slot to connect your monitor, and this is a full-fledged computer. I'm not sure whether you have heard about it or not. Just try to Google it, right? And you can literally do programming into it because it comes with a Linux operating system, or you can install Linux operating system. Means a PC less than 1000 rupees. If you already have your monitor, keyboard, and you can literally, because this is a Linux based system, Python is already built in into it. You can install the Python. This also comes with a wireless card nowadays, right? So the whole sole point is here also we are, and Raspberry Pi sales were skyrocketed in last 3 4 years because people are doing their project. If nobody has money, means in today's world, if people do not have money, they can start right here. They do not need to buy a full-fledged computer. They want to learn Python, they want to learn programming. We have a solution for that, right? The whole sole point is I want you to make understand Linux is one of the most widely used operating system. And if that is the case, then why not to learn it? What is the reason to not? And although I can understand that the window is user friendly and that's why anybody can learn, right? But if you spend maybe 10 15 hours in Linux, you are going to be deeply in love with that, right? This kernel plus UI thing is proprietary for Windows, and that is why the terminal which Windows offer, the command line, right, doesn't have much options. Why? Because you cannot run you cannot do many things because this operating system is tightly written by Windows, right? You cannot, it's not an open system. But if we talk about here, the kernel is open, right? And if we talk about any Linux version, maybe Ubuntu machine, right? If you take this machine, Ubuntu machine, the command line or terminal it offers you can do wonders, right? There is no limit what you can do with this Linux operating system. But Windows, as you know, Macintosh, as you know, those are closed system, and those has to be because those are proprietary solution, right? But Linux philosophy is different. They have made it open for everybody. And believe me, when they have written this kernel code in the start, maybe 1994, the code length was really small, maybe few thousand, means 10,000 lines of code. But now it is in millions. And this cannot be done by one person because Linux is open. Many people are contributing to improve the kernel because many people can use it, right? And there is a huge community for the Linux users. And that is why we have many tools available which are specifically for the Linux itself, which you can do a lot of things, right, with the command line itself. And that is why I would like you to be pretty good with respect to Linux operating system. And that is why I want at least 10 to 12 hours should be, you should spend in the Linux, right? Interesting. So now today class, I wanted to tell you that how we are going to proceed with respect to the lab. What I want from you guys is that you should be having an Ubuntu machine with you. There are multiple ways you can do it. And the reason is whatever the things we are going to learn, it is your duty to check it on your Ubuntu machine, right? I can show you mine, how I built it. But if you have a laptop of 8 GB RAM, right, maybe a quad core processor or a simple processor also, what you can do, you can install EVNG on top of it. And this is your maybe the assignment for the next 2 days. If you do not know how to install, just write on Google how to install EVNG on Windows or Macintosh laptop, right? If you are not comfortable installing EVNG, then we need to figure out some more ways like Google Cloud Platform. they are going to give you machine free of cost, right? Where you can run Ubuntu, right? Or you can install even G2, because in this case, we do not need so much machine power, right? We do not need the machine power like SD-WAN labs. I have created my own on the GCP. You can do, right? If you do not want to install EVE-NG on your system. But the benefit of installing EVE-NG on your system is that if you do not have internet connectivity, or if you are traveling also, right, you can definitely do the practice on your laptop itself. So the exercise is that just try to install EVE-NG, and then I will let you know that how to build this Ubuntu machine. If you know, that is perfectly fine, because I want that by the next class I will give you a idea about how virtualization work, how EVE-NG work, and then you should install this EVE-NG machine into your laptop so that we should be ready for the next 10 sessions. Having said that, this is what I had in my mind before starting this class. It is now up to you. If you have any doubt, any questions, please do ask. Or at least please tell me, am I audible? Okay, so I am, because Supreet has raised the hand. Yeah, Mr. Supreet, please do ask your question.
Hey Vishnu, for this lab thing which you just said, so can we use the same machine of Linux that we use for our SD-WAN classes?
Yeah, you can use the same machine. It's going to be
Yeah,
like
okay,
this.
man.
I will show you, right? Okay, if you can see, okay, here. Oh, the same thing. Let me log into that. So to begin with, I have just this Ubuntu machine, one switch, one router, right? And I will be creating the lab like this. But what you should have at least Ubuntu machine. Mr. Sultan, please do ask your question.
Hello, sir.
Hello.
Sir, yeah, when we provide latest iOS in directory in our Cisco switch or router, it is where it is actually located in ROM or RAM, or when we put boot system flash, from where it actually loading.
Yeah, so there is some, see, do not confuse with ROM or RAM, right? ROM is the place where actually you have one pre-configured thing, which has your post, which has your BIOS, right? So if you run your router, basically ROM will be the first thing which is going to get executed, whatever is written there, right? And here it will find that there is an operating system. For example, suppose if maybe in the computer or this router uh, space, router has this space, right? If you do the directory, it
Yeah.
will show you. So in that you can have two operating system. Maybe one is running 12 dot something version and the other one is running 16 dot version, right? So it also get confused that which to run. So basically, whatever you say in this BIOS, it is going to execute that, or it will give you the pop-up. So this is the part, just like your hard disk, where your operating system files are there. The ROM is something where your firmware is there or BIOS is there, right? And the third thing is going to be your RAM, random access memory, is also there in the router. If you choose to have the first program, it is going to be loaded here into the RAM, and then which we call, I think, there. I will let you know because I need to read about NVRAM and this. If I want to compare with the real operating system Ubuntu, that how iOS is, what we can say, structured, I will let you know. But for now, basically, this is what I can think of. But do not get confused with ROM and STD and RAM. Okay?
Okay, sir.
Perfect. Anybody else? Anybody else has any doubt? Okay. If not, that it was wonderful talking with you guys. Although you are uh, uh, quite silent, but maybe because we are discussing quite general things, maybe when we meet in the next class, when we talk about how to create this Ubuntu machine, and then we will talk about real Linux, how to effectively utilize that. Having said that, it was nice talking to you. See you.
Vishnu, I
Yeah,
have a
please go ahead.
question.
Prashantji.
Yeah. So
Yeah, Rahulji.
Rahul this
Yeah.
side. Yeah, Vishnu. So I do not have a laptop available with me right now for running the Evangi lab.
Okay.
So I'll be creating it either on the Azure or GCP.
Perfect.
So, but my question is, for how long we can run for a basic server on the or a machine on the GCP?
I believe it's for 3 months. They are going to give you around 20,000 rupees worth of points there, and 3 months is the time period for that. And if you change your username and card, then again 3 months, because they want you to effectively use. And we do not have much requirement here. I'm not asking for 16 GB of RAM. If you have 8 GB of RAM machine, it is going to be quite enough for this. Okay.
Okay. Okay, understood.
Anybody else have any doubt, any question?
Vishnu, is it possible to run Ubuntu on JNS 3?
Yes, absolutely, it is possible. But I haven't tried it. It is absolutely possible because I have seen people doing that. You can easily do that too. If you are more comfortable with GNS, please do that. And I would say, Prashantji, just take a note of that too whenever you do, because if people here want, then you can guide them too. At the end of the day, we are the same community. Okay. We are just helping each other learning, right? I learn from your questions, you learn from my boards, and this should be the community like this. Okay. Anybody else? Any question? Any doubt? If not, see you on Monday. So not Monday. See you on Friday, 10 p.m. sharp. Bye for now.